Good morning, everybody. I'm Tom Loveland with the USGS Aero Center in Sioux Falls, South Dakota. Since we all like to lead off with a little bit of our personal history, my confession to you all is that I took my first university course in remote sensing the semester before the launch of the first Landsat. So that dates me probably better than almost anything else. I've also had the pleasure of working for two state-level remote sensing programs in the state of South Dakota and Arizona over the years, and so the importance of the investment by states to deal with natural resources is something that's particularly important to me and to, I know, all of you in this room. Now, the Landsat legacy is officially 40 years old, but it's actually a part of a dream that came from the mid-1960s when there was the recognition that we could use imagery from space, from orbiting satellites, to provide a continuous stream of information that could help us to improve natural resources monitoring. And of course, the first step in achieving that vision began on the 23rd of July in 1972 when ERTS-1 was launched, then eventually renamed Landsat-1, and this is the first Landsat image, or ERTS-1 image, ever acquired over the Dallas-Fort Worth area 2 days later. This started that long legacy of trying to provide continuous observation of the Earth for the purpose of natural resources monitoring. Now, when we look at what we need for global monitoring on a continuous basis, there's some very simple elements that we have to satisfy. First of all, and probably as important as anything else, we need to have that consistent collection of measurements that correlate to the features on the Earth we're trying to deal with. And of course, they need to be at an appropriate scale. And in the case of Landsat, with its early 80-meter resolution, now 30-meter resolution, we are observing the Earth at a scale, at the field scale, that allows us to understand the impacts of our management decisions and as well separate impacts on the surface from human causes versus natural causes. So it's an important observation scale to work with. The other things we need are measurement continuity. If we're going to understand a changing Earth, we have to look at it continuously over time, and we have to be committed to doing that into the future. And that's, of course, one of our continuing worries within this community and many, many others. And finally, the other part of long-term monitoring that's important is that we have to have access to affordable imagery. And I'm happy to say, due to a policy change within the Landsat program 2 or 3 years ago now, we are sending out more Landsat data at no cost to anybody in the world than ever before. Years ago, before our free data policy, we distributed in good years 20,000 images. We are now distributing about 3 million a year, and the rates of use, the rates of downloading from our archive are rising still. They haven't plateaued. Well, let me give you just a status report of where we are right now with today's missions. We all know the incredible story of Landsat 5, designed for a 3-year life that lasted 27 years. We ceased collecting the thematic mapper imagery that included a thermal signal in November of last year due to an electronic problem. We are collecting the old multispectral scanner imagery over the conterminous U.S. It's going into the archive. Not a lot of demand of it, but we know we need to continue to document the condition of the Earth's surface for future generations that are trying to understand change. The satellite effectively, though, is so far past its design life and about to run out of fuel that we are expecting to begin the decommissioning process very soon. So essentially, the life of Landsat 5 is over, but it had a proud, incredible history. Landsat 7 is still collecting imagery. It has a very robust global collection activity over the United States. Every image is acquired on every orbital pass. As you all know, there was a mechanical problem, the scanline corrector failure in 2003 that reduces the information found within every scene, but the data are still quite viable. And the applications of those data, particularly now that they're free, is significantly on the rise. We currently expect, barring electronic or mechanical failure, continuation of Landsat 7 through 2017, at which point its 5-year life will come to an end, but it's already in its 13th year. So, again, Landsat 5 and 7 are really incredible testimonies to the quality of aerospace engineering in NASA and across industry in this country. It's something, again, we should be proud of. Now, in Sioux Falls, South Dakota, at the Aero Center, we maintain the Landsat archive. It includes much of the coverage collected around the world, but not all of it. Ground stations around the world have also been acquiring imagery since the early days of the program, and our estimates is that there are perhaps as many as 3 million images in international archives that are not duplicated by what we have in Sioux Falls, and we have an archive now of about 3 million images as well. Over the last 2 years, we've been aggressively working with this international cooperator network to repatriate or bring back that international imagery into the Sioux Falls Landsat archive. And I'm happy to say that in the last year, we've added almost 1 million new scenes to it. To our collection, and so if you're involved in international studies, the collection is getting richer every day. And this effort, these are the stations that have already contributed data, and there are more signing up. So it's a real significant investment in solidifying the investments we've made over the years from Landsat. Now, as we look forward, we understand that as more Landsat data go out, the needs of users become more sophisticated and more diverse. We are in the process of developing the capabilities to begin providing geophysical and biophysical measurements from Landsat, in addition to giving out multispectral images. We are in the process of developing those capabilities to provide surface reflectance, in fact, starting tomorrow, thermal imagery, perhaps in a year, calibrated to surface temperature, and other biophysical measurements that can be used by people with geospatial needs to understand the condition and the dynamics of the Earth's surface. Now, I mentioned that beginning tomorrow, we will be distributing prototype surface reflectance data. These are the reflected measurements converted to surface reflectance values, meaning the impacts of atmosphere have been removed or corrected for. It's based on something called LEADAPS, the Landsat Ecosystem Distributed Adaptive Processing System, and a global collection from 2005 and 10 will be part of this initial release. And if we find value, we'll move to process the entire archive in this way. Another development that we're really excited about is a change in thinking that moves us away from being scene-based, those old path rows, to being pixel-based. With data available at no cost, every cloud-free pixel now has value. There's no sense disregarding scenes with large proportions of clouds. Let's extract those clear pixels and put them into a seamless mosaic database that allow us to go to the single-day observations, but aggregated to monthly, seasonal, and annual variables, so we can start building that time series that you can extract windows of just what you need through the temporal slice that you're interested in. This is a prototype effort led by David Roy at South Dakota State University in cooperation with the USGS. Right now, for the conterminous United States and Alaska, we have Landsat 7 data from 2003 to 11. But as exciting as anything is that starting very soon, in cooperation with South Dakota State University, NASA Ames, and the USGS, we will be putting all Landsat data into the WELD format, available in this seamless clear pixel view, and this will go back through the entire TM record, and as well will include the OLI and TIRS imagery. So this will change the way we access data. This will reduce the amount of data handling, data processing we have to do as we try to investigate the problems we're dealing with. So I think it's a big step forward. I want to also mention that part of the process we use to make sure that we're making the right decisions for the users of Landsat data is to work with a team of people from across the country and around the world that are selected through a very challenging competitive process. The Landsat science team, sponsored by the USGS and NASA, has just been announced for the next 5 years. And this represents some of the real leaders in our community that will provide technical and scientific evaluation of issues related to Landsat and insights into the needs of user communities around the world and across the disciplines. And happy to say that the ET community is well represented in this, with Rick Allen and his team, Martha Anderson and her team included in this. If you have issues, work with the membership of this to help bring the ideas or the challenges you see to the forefront. They are the eyes and ears of the community. So the last thing I want to say is global monitoring is a great idea. It's proving its value. The innovations we're seeing because of the free data policy are so remarkable, you wonder why we didn't do it many years ago. At the same time, we also know that the investments we are now making to make more effective use of Landsat are in danger if we don't continue our long-term commitment to the program. And so when we come to the end of the design life of Landsat 8 in 2018, we're going to be anxiously looking forward and worrying about what's next. And so all of us in this room are, I know, worried about Landsat 9. USGS and NASA are in constant conversations about how to ensure the fastest path to Landsat 9 in a way that doesn't compromise the capabilities that we have had in the past. But it's a delicate process, and this is one of those areas where every one of us together has that responsibility to communicate the value of the program and to educate people on how important it is for continuing it. And with that, I thank you.